Okay, so these are the notes for page 3 of our Chapter 7-6 notes. We're going to go ahead and cover the entire page, so up at the top is going to be a little bit of review of the stuff that we've done the last couple of class periods. So you'll notice that some of these look like warm-up problems from the last couple of days. So if we take a look at question number 1, one of the ways that we can handle it, and we talked about last class, is just being able to rewrite this using the whole transformation or translation between an exponential and a logarithm. So if we see the variable is in the exponent, we can go ahead and just rewrite this. So we can do log, and then remember the base of the exponential here is going to be the base of the logarithm itself. So I'm going to take a look at the base here of the exponential is going to be the base of the logarithm. And then we can also take a look at, remember we would jump across the equal sign to grab the exponent. So I'm going to go ahead and put my equal sign here. I'm going to jump across the equal sign to grab the exponent. So there's my exponent, and then we jump back inside itself to grab what we were actually equal to here. So that is one way to write your answer. Additionally, we could go back to the process that we talked about a couple of class periods ago, where in order to bring the exponent down, we can apply the operation of logarithms to each side. So we could do log, again, choose the base that you want. I'm going to go ahead and choose a base of 10, just because all of the calculators have that. As soon as I do that, keep in mind that this whole thing is inside the logarithm. I can get the x to come down in front, and then I would just go ahead and divide by log 5 to get the x by itself. So this is another process that we could follow. So we could say that x is equal to log of 8 over log of 5. Again, it doesn't matter which of these answers you choose to do, so we could do that as our answer, applying logs to both sides, or we can do this as our answer, just rewriting it as a logarithm itself. Okay, then moving on to number 2, now we're actually talking about a logarithm. So if it were me, I'd translate it back into something I'm a bit more familiar with. So I'm going to start at the base here, and I'm going to jump across the equal sign to grab the exponent and then come back to figure out what it's actually equal to. So this is going to give me x cubed is equal to 125. All right, this is something that I could have handled well before we got into this class. So I would go ahead and cube root each side. Doing that, the symbols cancel themselves out, and then the cube root of 125 is just 5. So x is equal to 5. Okay, moving on to the next question. I notice that the x is trapped inside the logarithm itself, so I need the logarithm to go. You take a look, I've got a log on the left-hand side. I do not have a log on the right-hand side, so the best that I can do at this point is rewrite it like the previous question. So start at the base, jump across, and then come back inside. So that's going to give me 2 to the 7th is equal to 3x, something I can totally handle because the variable isn't in the exponent and it's not trapped inside the logarithm anymore. And then 2 to the 7th I know is going to be 128 equals 3x. I'm going to divide by 3. And if that divided or simplified, I would go ahead and do that, but I don't believe it does. So I'm just going to leave it as x is equal to 128 over 3. Okay, you'll notice similarities, but very strong similarities between example 3 and example 4. So I would go through it and try to rewrite this one as well and then solve. So I'm going to go ahead and pause the video, work out the problem. If it were me watching this, I would probably pause it as well and then see if I could do the problem and then check your work. Okay, so I went through and I rewrote this, and then I ended up with this whole 4 to the negative 1 business, which I don't want to keep a negative exponent in the problem. So, as you recall, I can go ahead and use negative exponents to translate it into a fraction. So I'm just going to change its location in the fraction. So if it's up, move it down. If it's down, move it up. So I went ahead and moved it down to be a 1/4 and then added the 3 to the other side. So if I'm adding two positive numbers, one being a whole number and one being a fraction, I can really just kind of smash them together to get the result here. And that covers the first 4 questions. Moving on to the next page. All right, so a continuation here. You'll notice in question number 5, and we're now utilizing some of the properties that you guys established last class. So if you take a look at just the left-hand side, so I'm ignoring the 2 at this point, the logarithm bases match. They do not have coefficients at all, or I would deal with those first. But I do see subtraction, and we did make the connection last class that if I wanted to condense it, which I do, I've got too many logarithms basically at this point. If I want to condense it, then I'm going to go ahead and turn my subtraction actually into a division problem. So bases match. I can do this, so I keep the log. Notice that I have both a positive logarithm and a negative logarithm. Negative telling me I need a fraction bar. The 6 comes from a positive logarithm. If I look at the sign in front, there is no sign in front of the logarithm here, then I know that that is a positive sign. So that tells me that the 6 is going to go on top. Likewise, if I take a look at the second logarithm, I see that the coefficient is negative, which means that the x is going to go into the bottom. And then from here, I'm just going to go ahead and finish writing the rest of the equation. So just kind of drop the 2 down with you. At this point, the logarithm owns everything on the left-hand side. If it does that, then we can rewrite this as an exponential. Well, knowing that the base of this logarithm here is 10, if there's nothing, then I can jump across the equal sign to grab the exponent and then come back. So I think that we're going to end up with 10 squared is equal to 6 over x. And then 10 squared is going to be 100. 6 over x. I think most people make the recognition to kind of cross multiply if you put the 1 under there. So if we cross multiply this, you got 100x is equal to 6. I'm going to divide by 100. That's going to give me 6 over 100. However, that can be simplified. So I think that that is going to give me 3 over 50. And that is going to be my answer. X is equal to 3 over 50. Okay, I'm going to go ahead and take a look at the second one over here, number 6. I do want to condense, which I can do because the bases of the logarithms are the same. So I'm looking at those guys right there. If they are, then I can go ahead and condense them. But remember, you have to follow order of operations. So if you see coefficients and addition and or subtraction, coefficients have to happen first because that's your exponent. So I'm going to take this 2 coefficient, I'm going to actually move it up there as my exponent first. So I'm going to rewrite my log base 4, for that is going to become a 7 squared, and then bring down my log base 4 of m. If there was a coefficient there, I would have taken it up as an exponent as well. I'm going to go ahead and clean this up a little bit. So that's log base 4 of 49, just going ahead and squaring my 7, and then bring down my log base 4 of m and my 3. Okay, on the left-hand side, I now see this addition sign. So this addition between my logarithms, notice that neither of the logarithm is negative, so I can condense this. I don't need a fraction bar because there's no division here, and the bases do match. So I can condense this into a log base 4 of, don't need a fraction bar, no negatives, I have a 49m is equal to 3. Okay, looking at this point, I have a logarithm that owns everything on the left-hand side and then just a plain old number. So now it's back to stuff we've just been doing. So start at the base, jump across to grab the exponent, and then come back. So it's going to give me a 4 cubed is equal to 49m, something I can totally handle. That gives me a 64 equals 49m, and then I'm going to go ahead and divide. I think I get 64 over 49. And that's my answer for that question. Let's take a look at question number 7. Question number 7 looks slightly different. Not terribly different, just slightly. I have logarithms everywhere now, so I'm just going to pay attention to the left-hand side. I see multiple logarithms on the left-hand side of the equation. Both have a base of 10. Neither one of them have coefficients, so I think I can actually just handle that plus sign right now. So taking a look at that plus sign, it's telling me that I'm supposed to multiply when I pull my logarithms together. So I'm going to do my log, and then I'm going to multiply the 5 and the 8. And then I'm going to drop the right-hand side. I'm going to go ahead and multiply that 5 and 8, and that's going to give me 40. And then drop the log as well. Now, what makes this one different, and actually really kind of nice, is if you take a look at the statement, really kind of step back and take a look at it, the only way that this is true is if x is equal to 40. And the beautiful part about that, or one of the things that's really nice about this, is that if you have a logarithm with the same base owning the left-hand side, and a single logarithm with the same base owning the right-hand side, the logarithms can be neglected. Like, you can just ignore them, because what must be true is that the inside statements must also be accurate. So I think we can just say x equals 40. And I think that that covers the first top 7 questions. So moving on to the next ones. We're going to go back and kind of take a review of stuff that we did back in Integrated 1 when you guys did the bouncing ball activity. So we know that every single ordered pair here, regardless of what those points are, is just an x and a y. So I know that that is just an x and a y, and I also know that that is just an x and a y. So what I'm going to do is I'm actually just going to plug them in as x and y into the equations. I'm going to create a system of equations actually to be able to solve this. So if I take a look at the equation itself, I'm being told that I'm supposed to use y equals ab to the x. So basically being outright told that there is no horizontal asymptote, so I can neglect the fact that there might be a plus k. So I'm just going to go ahead and plug these in. So that's going to give me 36 is equal to ab squared, and then I'm going to go ahead and create it again using the next point. So 324 is equal to ab to the 4th. Now there's a whole bunch of different ways that you can handle this. You can do substitution. So you basically created a system of equations. You could do substitution, you could do elimination. It's ultimately up to you. I have found recently that one of my favorite ways to do this is elimination. So if you take a look at the two equations, I want to look at the equation that has the smallest exponent on b. That's really what I'm focusing in on. So this equation, in comparison to the other one, the b has a 2 exponent on it, which is smaller than the one on the right-hand side that has a b with a 4 exponent on it. So what I'm going to do is I am going to take the one with the smaller exponent, and I'm actually going to divide it into the other one. So I'm going to take this blue equation over here, and I'm going to put the smaller one underneath it. So I'm going to put a 36 is equal to ab squared. And this is a form of elimination. So I'm going to go ahead and actually divide. So if I do 324 here, let's try to keep my stuff highlighted so we can see what I'm doing. I'm going to take this 324 here and I'm going to divide it by 36. If I do that, that's going to give me a 9. Then I would go through and divide, so just drop the equal sign. If I go through and divide the rest of them, well, a divided by a, those just disappear. So these ones cancel. That's kind of nice. There's my elimination happening. Then I would take a look at the ones next to it with the b's. So I have my b to the 4th divided by my b squared. Well, going back to the properties that we talked about last class, if you're dividing and the bases of the exponential are the same, you subtract. So I would do 4 minus 2. Okay, so now I would just solve. To get rid of the squared, I would square root. Remember that this is an exponential equation, so no plus or minus on this. We only want bases that are positive. So I think our b is just 3. Now, go back to the original equations. Pick the one that you like the best. I like the 36 because it's just smaller. So I'm going to take this, I'm going to plug it into one of my original equations of 36 is equal to AB squared. And then go ahead and plug in what you just found. So B is going to be 3. Simplify. It gives me 9A. If I divide, I think A is 4. So now I have everything that I need. I've got B is equal to 3 and A is equal to 4. And all I have to do is write my equation. So I think my equation is going to be y is equal to my A value, which was 4, times my B value, which was 3, and then my exponent of x. That's it. 2 is just like that one, except now I have this plus k business happening, which means I have a horizontal asymptote, and I have to be told where that is, which I am told where that is. I was told that my horizontal asymptote here is going to be at y equals 2. So that means k is 2 when you plug it into the equation. So I'm going to go ahead and just basically do what I did this last time. It's going to plug these in as x and y. So that's going to give me 47 is equal to AB squared. Don't forget the k value this time. I believe is going to be a plus 2. And then my other equation is going to be 1217 is equal to AB to the 5th, again, plus 2. So before I do this whole division thing, I've got this mixture of addition, subtraction, or addition and multiplication happening at the same time. You got to move the 2 over. So I'm going to subtract the 2 over here, and I'm going to get a 45 is equal to AB squared. And then I'm going to subtract the 2 over on the other one, get a 1215 is equal to AB to the 5th. Now you proceed just like you did on the previous problem. So I'm going to go ahead and pause, and I'm going to work out and find my first variable. So I would pause if I were you and just kind of see if we get the same thing. Okay, so I went through and I stacked them up, knowing that I want the b with the smaller exponent to be underneath, so that when I divide I get a positive exponent, basically. I went ahead and divided my 1215 and my 45, gives me a 27. Notice my a's cancel, and then my b's do divide, but when you're dividing, you're technically subtracting the exponents. So I get 27 is equal to b cubed. I know to get rid of a cubed, I'm going to go ahead and cube root. So I think b is going to be equal to 3. And then go back to whatever equation you like. I like the smaller numbers, so I'm going to use the 47 is equal to AB squared plus 2. And then plug in what you found. Just remember to follow order of operations. So move that 2 over, and then go ahead and divide. Looks like A is going to be 5. And then from here, just write your equation. Don't forget to put the plus k, or the plus 2 in this case, back into your equation. So my a, b to the x, and then plus k. And I believe that that is our answer to this question. And that should cover the notes for this page.